Welcome back to our system design series. Today we are going to talk about a very popular caching strategy called caching aside, also known as lazy loading. This approach is widely used, especially in systems where it's crucial to boost read performance while maintaining a straightforward architecture. So, let's ask ourselves a question: what is exactly caching aside? So, let's make a quick example to understand what's going on here. Let's say that we have an application and we have a cache and we will have a database. No, back, copy, and yeah, a database. Okay, okay, this is, I guess this looks good. So in a caching side strategy, the cache sits on the side of the primary database, and the application is responsible for managing the interactions with both the cache and the database. Unlike some other caching strategies, the cache and the database have no direct connections at all. All operations are handled explicitly by the application. How does this work? Let's say that the application needs to fetch some data. It first check this data in the cache. Okay, and it will check it first checks the cache to see if the data is available. This known as cache lookup. Okay, and in the future we'll talk about what is a lookup and cache hit and cache misses. If the data is found, the cache the data is found in the cache. This is called a cache hit. The application reads the data from the cache and returns to the client. So basically, if the data is available basically in the cache, it will be sent back to the application, and this we call a cache hit. If the data is not found in the cache, we call this a cache miss. When this happens, the application has to do some extra work. First, it queries the database to read the data. So it will query this database to try to read the data. After retrieving the data, it returns results to the client. Okay, so the results will be returned. And let's assume we have a client here, and the the application will send the data back to this client. It also stores the data. Again, it will store this data into the cache. So the subsequent requests can be served from the cache, resulting a cache hit again. This approach is quite effective for read-heavy workloads as the cache helps reduce the load on primary databases and speed up response times. Systems using a cache aside are generally resilient to cache failures because, in the worst case scenario, the application can always fall back to the database for data. So let's consider an example for that. Imagine we have an e-commerce. You can see this as a good example. So imagine this is an e-commerce, and users frequently access product details. And instead of hitting the database every time a user wants to view a product, the application first checks the cache. If the data is present, it quickly returns the product information, reducing latency. If it's not, basically the application queries the database, returns the data to the user, and stores the product details in the cache for future use. What is the benefits from this strategy? The first thing will be the flexibility. Flexibility. Stability. I don't know. I'm trying to work on my writing skills here. So one of the benefits of cache aside is its flexibility. The data model in the cache can be different from the data model in the database, which means you can store pre-computed or aggregated results in the cache, simplifying application logic for subsequent reads. Also, there is a big benefit of fault tolerance. Fault tolerance. How you pronounce tolerance? Tolerance. rinse. Yep. So if the cache cluster goes down, for example, the system can continue to operate by doing directly the by going basically directly to the database. This makes the cache aside resilient approach for caching. But there are a lot of drawbacks. Not a lot of drawbacks. There are some drawbacks, to be honest. The first thing, we will have a cache inconsistency. This is one of the drawbacks. Inconsistency, because consistency is pretty long to type consistency, so I only type C. So one of the key challenges with a cache aside is the cache inconsistency. When data is updated in the database, the cache may still hold an outdated copy. To address this, we should like to address this. We should, all developers should often use a time to live values for cache entries, allowing stale data to be evicted after a certain period of time. Alternatively, developers can invalidate the cache when writes occur, for example. Also, there is a cache miss penalty. Cache miss penalty. Let's go a big P here. So the first time data is requested, it will always result in a cache miss, which means the full latency of querying the database. This can be mitigated by like warming up the cache, like preloading frequently requested data to reduce initial cache misses, for example. Um, we can, I guess it's a good, I guess this is a good thing. Like, yeah, I guess we are in a good stage right now, because we talked about the cache, the cache aside pattern. What is it, the benefits of it, and the pros and cons, and we need to understand when to use it. I guess it's pretty important. Like, you have, if you have a read heavy workloads, a really read heavy application, and the same data is requested multiple times, or you want a manual control over when and how data gets cached, if you really want to control what happened, your cache. Also, and if the cache failures shouldn't bring down the system, your application can tolerate some requests going to the database instead. If that was okay, you can go with cache aside. And I'll be honest with you, this is one of the most common strategies to be used. So in this video, we explored the cache aside and the caching strategies, a commonly used approach where the cache sits on the side and the application explicitly manages basically data operations. We discussed its advantages and its such as a fault tolerance and flexibility, as well its challenges. And yeah, if you like this video, please make sure to subscribe and hit the notification bell so you'll never miss any video. And if you thought that I'm talking too fast, I am so sorry for that, and I will try to talk slower in the future. So see you soon.